warm welcome back to you, our watchers, at the A4Q Testing Summit 2024 edition. With me today, I have Olivier Denoo, the VP of the ISTQB, and a returning speaker to the A4Q Testing Summit. Olivier, it's such a pleasure having you with us today, and I'm so excited for your presentation.
Thank you. Hello, everyone. Shall I start now?
Sure, go for it.
Let's go. So, ladies and gentlemen, how many times have you seen a war or action movie with de-escalation or negotiation at its heart? Well, there are a few, negotiation, but they only represent a tiny fraction of the genre. If AI played war, how would it resolve the conflict then? Because AI, as you know, is fed with data, and data is coming from the web, from different sources, from action movies, from Hollywood, from everywhere. So if you give that sort of data to an AI and say, let's simulate a conflict, how do you think that the AI would solve the conflict? Well, actually, this is the experiment that the Department of Defense just started a couple of months ago or years ago. And actually, they started simulations where different situations of war or pre-war situation would be witnessed by the AI. And it's starting from just a verbal offense, this kind of verbal escalation that starts before every conflict. Like a little bit, I push you a little bit and see how you react and so on and so forth. And to a real war situation when there are, war actions, troops entering a country or missiles being launched. And they were asking the AI, okay, how would you end up the conflict? How would you try to solve the problem that we're facing now? And guess what? In 90% of the cases, the AI reacted with a big escalation that ended up in real war situation. Even if it was just a verbal offense, it was escalated to such a point that the only solution was to start a war. Frightening, isn't it? So this is some sort of a bias. The information that has been fed in this situation is basically biased because there are many ways in real life where we can solve conflicts without starting a war, fortunately for humanity. So what is a bias actually? Algorithmic bias describes a systematic and repeatable error in a computer system that create unfair outcomes, such as privileging one category over another in ways that are different from the intended function of the algorithm. I'm not going to read the rest of the slide, but yeah, you get the idea. The algorithm is getting wrong data or biased data, and it starts making differences that are not expected and privileging one category over another. That is basically the definition. Okay. But fine, where these bias come from? How comes that we have bias? What I'm going to describe now is a big LLM system, the ChatGPT type. And we will try to see in the different operations that are used to create this ChatGPT ecosystem where the biases can be introduced. So that's what I call the anatomy of a bias. And basically speaking, at the origin, you have a problem to solve because artificial intelligence is just a piece of software, actually, and that piece of software is just there to solve one's problem. And one's problem is described within requirements, or what we call user stories these days, or epics, or whatever, if you're more agile. But basically speaking, that's the place where you describe the problem. And we know from people like Tom Gilb for years that these requirements, if they are poorly designed, if they are poorly engineered, they lead to about 60% of the problem that we find, call them bug or defects or whatever terminology you want to use, or failures. But basically speaking, they come from poor requirements or poorly engineered requirements. The first example there was Thai. Thai was a chatbot, artificial intelligence from Microsoft. And Thai was designed to interact with Twitter, now called X, thank you, Elon. And the requirement was just there, okay, learn the interaction with human being, with real humans, and learn to be human, basically. It was a little bit light. And after a couple of hours, the Twitter sphere, real people understood that Thai was just a chatbot. And because Thai was just a chatbot, they decided to play with chat and decided to input answers and interactions that are totally improper in order to play Thai. And in less than 24 hours, Thai moved from the, little gentle, naive AI, I want to learn to be human, into a real web monster that is racist, that is hating women, that is willing to have sex with everyone on the web, and so on and so forth. It went to such an extent that Microsoft decided to stop the experiment after less than 24 hours. This is how poorly defined requirements lead to a big bias. Okay, the next step is basically training data. So once the problem is defined, you have some sort of data that you will use. Actually, you have a big set of data, and you will divide the set of data into two categories. One that will be used to train the AI, call it the test data, that test data that you use in order to test your application, compared to production data, which is the whole world, the rest of the data in the world. So this subset of training data that you use might be biased, might contain bias, and that you don't notice. Very, very simple example there was face recognition system. Face recognition system, you know them probably if you travel a little bit. You have this camera in the airport checking your face and checking your ID on the other side, or passport on the other side, and just comparing them and say, oh, this is Mr. Denoo, and you're allowed to cross the border and take your plane, basically. Well, Microsoft and Amazon built big face recognition application, AI, in order to resell or to reuse within their ecosystem. The trouble was that these face recognition were trained with essentially Caucasian kind of faces. So not a lot of African faces, not a lot of Asian faces. And the trouble was that when it was exposed to a real life situation in Asia or Africa, it couldn't tell one person from another. So again, this model had to be retuned or simply stopped, because it was not possible to really have the accuracy that was required from them. On the other side, you probably have the same sort of models that are working with Asian faces in China, because China is also a very advanced country in artificial intelligence. But I guess that they're probably facing the same trouble with the European Caucasian kind of faces. On the other side, let's go to the next phase. You have what is called the labeling. And the labeling is, basically when you have a subset of data that you're training, these data are used to train, but you need to tell the AI what the data is all about. So for instance, if you have an AI that is sorting picture or telling what is on the picture, so that's image recognition kind of AI, well, you need to tell the AI what is exactly on the picture during the training phase. This is called the labeling phase, actually. So this is a cat, this is not a cat, this is a dog, this is not a dog, and so on and so forth, okay? The trouble with these labeling approaches are that because people want to cut costs and save money, these labelings are made in centers in developing countries. And, well, I would say that there is a risk there. not that developing countries can't tell the difference between a dog and a cat or a dog and not a dog, but basically in some more difficult situation where cultural parameters are involved and so on and so forth, it might be, of course, more questionable. Other possibility as well, if these labeling centers are not well managed, there might be, of course, a possibility for adversarial techniques or sabotage to happen, of course, in order to compromise the project. The next phase after labeling is basically having the algorithm processing the data. And algorithm processing the data is always okay if the data are what you expect them to be. Another example here of that's not really artificial intelligence, but it's very close to artificial intelligence, has been seen with Knight Capital. Knight Capital is what is called a fast trading company, or it was a fast trading company because it went bankrupt after this case. Basically speaking, what it does is that it takes position of certain companies in the stock exchange. They wait a little bit for the price to raise a little bit, and then they resell. So that's buying and reselling. But these operations are extremely fast. I'm talking about microsecond and even less than microsecond in some cases. So time is really the key here. It needs to go extremely fast. Here the trouble was that Knight Capital had to upgrade the software because the stock exchange ecosystem has changed. And for some reason, again, to cut costs, they decided to reuse some parameters that was in the software. So they reused some variables that were defined in the software, and they decided to use for another purpose. And they started the rollout. The problem was that when they roll out of 8 machines that were in production, only 7 were rolled out properly, and the other one was still using the parameter the old way. It resulted in a terrible situation where the algorithm was there to seek for a position and buy as many shares as possible from that position without looking at the price, without looking at reselling them. It was just there to acquire the universe, if you get me right, okay? At a certain moment in time, the stock exchange just realized that there was a problem, and they decided to, do something about that. And well, Knight Capital was, of course, very well aware that something went wrong as well. So they decided to roll back because they thought that the changes they made were at the origin of the problem. And because they rolled back, now you had not only 1 machine that was going wrong, but we had 8 machines again that were going wrong. So it inflated and increased the problem exponentially to an extent that the stock exchange had to be suspended. And Knight Capital at the time was acquiring positions that were exceeding their own capital. So basically, they were virtually bankrupt. They were bought by another company, and they just went out of the picture a couple of years later. So that's the sad story. And this is because these fast trading algorithms are acting that fast. So there's no way to just say, okay, let's break, let's stop. That's not that easy. Okay. The next step here is reinforcement and supervision. You don't have that layer everywhere, but ChatGPT, for instance, has this kind of reinforcement or supervision. Why is that layer there? Well, that layer is there because of TIE and because of the TIE effect, basically. So people just want to make sure that everything that is getting out of the AI is reasonable enough not to be exposed, and making the headlines, basically. So, while still in the training phase, a couple of people are just checking that the output from the prompt that was input in the system, the output is valid, is clear, and it's not arguable to a certain extent with regards to, let's say, ethics or explicit content or biases, basically gender biases or whatever. The problem I have possibly with the reinforcement or supervision is that that's all right, But who is reinforcing? Who is supervising? Who is deciding what is acceptable and what is not acceptable, and based upon what standard? I mean, culture and standard, ethical standard. For instance, basically speaking, I must say that most Europeans do not agree with the way that America would consider very touchy topics like abortion, for instance, maybe other kind of topics. When it touches, these very, very sensible and sensitive parts of humanity, like religion, like ethics, like culture, these kind of things are extremely touchy. Trouble is that in most cases as well, these reinforcement or supervision are made in centers. And because people like to cut costs, these centers are, of course, localized in, again, cheap labor countries. Again, nothing against cheap labor countries, but I'm not sure that these guys have the same sort of culture and value that, as the American or the European or the Chinese or the African people, whether it's North Africa or Central Africa. There are still, of course, loads of cultural difference. And even if you just consider Europe, for instance, we have a big spectrum of differences here and there, depending on where you sit in Europe. So definitely not something easy, and definitely something to have a look at it. Okay. And once this reinforcement is done, then you have another risk and another possibility. And I just had to consider this new risk very recently. Well, in the last 3 to 4 years, when models like ChatGPT or Midjourney or whatever have just been launched, we produced more contents with artificial intelligence than we ever did for the last, let's say, 30 years. We produced more AI-generated images in 4 years than we did for the last 30 years. All kind of contents, whether it is digital or not digital. We produce much more than this. And the trouble is that if we feed the AI with their own content, I mean, if we use these AI generated pictures as new training data, so back at the very beginning of the model, then of course we have this kind of incestuous auto-feed loop. And this is basically a reinforcement in a closed loop. Okay, you might say, yeah, so what? What is the risk in there? Well, the risk is there that you might consider the AI reinterpretation of, let's say, Dali or Van Gogh or whoever famous painter you like, as real content. And basically speaking, the number of references that are referring to the real picture, the real McCoy, the real Van Gogh, or the real Dali, or the real whatever, Da Vinci, is decreasing statistically speaking. So basically you have maybe, let's say, 10,000 references of La Gioconda from Da Vinci, but you have probably 1 million references of AI modified Gioconda from Midjourney or whatever kind of AI you're using. And the trouble is that, statistically speaking, you're diluting the value of the real one compared to the modified one. And because the AI is simplifying the language over the time, there are studies, and I will reference these studies in the end of the presentation. Basically, you just have the real value is fading out, and you're just getting less and less reality and more AI, and less and less qualitative AI, basically, which is what is demonstrated in these studies. Okay, so what is important is that we must understand that the problem is there to be solved by a piece of software. And at the other end of an AI, not using AI just for the sake of it. At the other end of the AI, there are people and real life consequences. So AI is already there for years, or their primary versions, to allow us for, credit, give us, banking system, give us some credit, or calculate our solvency index. Car life insurance premiums are calculated by these kind of software. Now we have employment systems that are using AI for kind of pre-interviews. We have AI that is also acting in studies in justice. I will just give you an example in a minute. But also for love, because basically you have this Tinder kind of stuff. And this is also matching algorithms. These are AI matching algorithms there. So AI is now ruling more or less our world, or more interacting with the real life of real people. The two books that I'm referring here to is, well, first of all, there's one from a French journalist. Unfortunately, it's in French only, but this is a French journalist that is very preoccupied about her Tinder scoring index, because she wants to know, she's very preoccupied about how attractive she is. She is single and she wants to find love, of course, so she believes in Tinder. And then she discovers that Tinder gave her an index, kind of attractivity, a female attractivity index. And she wants to know, because she wants to know how Tinder can, score her attractivity. Interesting one, but limited kind of interest. Weapons of Mass Destruction from Cathy O'Neill is a reference in terms of biases, and she just exposes a couple of already big biases with consequences within the American society the last 10 years in the education system and other systems. Very interesting to read if you're interested in this kind of concerns. Okay, an example of biases in justice. So we had in the US, and they're still there, these AI facilitating the decision made by the judges with regards to a certain offense. So you have an offense that is committed, and the AI is just questioning through a questionnaire. They're just analyzing a questionnaire that is given to the offenders, and based upon the questionnaire, the AI defines the probability of recidive, so the probability that someone commits another offense in a short period of time. There was a famous case there where you had two persons that were caught the same day. One committed an offense that was a robbery, and the second one was also stealing a bike. So here they are. You have Vernon Prater, and Vernon Prater had prior offenses, so 2 armed robberies, 1 attempt armed robbery. And, well, the guy was caught red-handed, I would say, and he was about to be judged that day. And on the same day, Brisha Borden, who was a teenager at the time, just stole a bike because, well, I don't know, she was too lazy to walk home, I suppose. And then she realized that it was definitely not a good idea. So she went back to give the bike back to the owners, but the police was there waiting for her. She was caught, and though she was just, let's say a teenager with a difficult life, so 4 juvenile misdemeanors, but nothing really serious actually. The probability of recidive that was calculated by the AI was much higher than Vernon. So Vernon was released on probation, and Brisha Borden was sent to jail. The trouble was that Vernon made a subsequent offense right after he was released, and Brisha never had this subsequent offense done, but her life is definitely destroyed. The big difference is that she's black, he's white. And the questionnaire, funny enough, never asked anything about gender, never asked anything about skin color or whatever, but it was inferred from the questions that were raised. So where do you live, and so on and so forth. So these questions were just building up the case while not asking the question directly. You might believe that, we learn from that. But basically speaking, again, in 2019, AI is going to be used for the same sort of cases, well, a little bit less important cases in any case, in Estonia. So it's getting to Europe as well. Another interesting case here is about Chicago police. So Chicago police were using AI to predict the crime. You know, it's a little bit like this movie with the Minority Report, you know, with Tom Cruise, where you can predict where the next crime is going to happen. And based upon real data, so this is private data from the police, Chicago police, they just analyzed the whole bunch of data, training data, and the artificial intelligence just decided which area is at risk and which is less at risk. So they predicted where the next crime is coming in. And of course, when you're a policeman and you know where the crime is getting to hit next time, well, you send more policemen. Trouble is that these policemen are trained to seek for problems. And of course, they find a lot of minor offenses here and there. So they report it back to the AI, and this is fed back into the model. So because you have more policemen, you find more little offenses here and there, or little crimes here and there. So of course, this area becomes hotter and hotter in terms of crime. So the model is fed back, and it's inflating exponentially, with a result that because you have limited police forces, you have all the policemen getting to a couple of areas and leaving the rest totally unsecure and unprotected, where nobody goes by, because then the crime understands that this is the next interesting spot. So basically speaking, this is another risk that you have when you retrofeed the AI with their own data. Another case, interesting as well, is what is happening in China in some cities, and the city here is called Ningbo. And basically, there are face recognition cameras in a couple of areas in the city, and they just spot, you know, these zebra paths. So when you cross the path and it's red for the pedestrian, well, the camera spots you. You have the AI face recognition system that is there because they have large banks of pictures, and it says, hey, you just committed the offense, and they just show your picture on a big wide screen everywhere. And what happened there was that this businesswoman, Dong Mingzhu, was displayed in the Hall of Shame because she crossed the zebra path. The problem was that this lady was 3,000 kilometers away. And what happened was that her picture, because she's a famous businesswoman, her picture was there on the bus. As you can see on the picture, if you can see that on the picture, her picture was on the bus. And the bus was, of course, crossing the zebra path because it was red for the pedestrian, so it's green for the traffic. And the camera spotted her face, so she was called guilty. And actually, she was not even there. So this is also a risk when you leave the AI totally unattended. Okay. Another big stuff with regards to AI is the need for explainability. And explainability is, how can you explain that you get a certain result when the AI is analyzing the situation? I'm doing a lot of translation, for instance, ISTQB syllabi or questions, exam questions, and so on and so forth are translated. And I'm using an AI-based system that is called DeepL, a very good one, by the way. But the trouble is that if in some cases, the AI just goes completely berserk, and in some cases, it is very hard to detect. So for instance, here, when you have conducting review on small chunks, it can come to a totally different translation, whether you activate the glossary. So this is the control vocabulary, so that you ensure a certain consistency in translation when you encounter some words. So for instance, testing is always called test in French. And, well, it can be something else like essay or whatever. There are different translations possible. We just ensure the consistency. So this is why we have a glossary. When you activate the glossary, you have one translation. When you deactivate the glossary, you have a totally different translation. That's all right. This is what the glossary is made for. Unfortunately, in this case, it has nothing to do with control vocabulary. So this is totally going berserk just because you adapt the parameter. How can you explain that? I have no idea. So this is an explainability issue with the AI. How can you make sure that the AI, keeps, let's say, stays in the borders and does not go berserk? Well, one way, and this is the traditional European way, is to legislate, to put conditions and so on and so forth, constraints in regulations or in law. The trouble, of course, with legislation is that not everywhere in the world we have the same vision on law. Well, first of all, we have different systems, and second, we have different feedback. We have different sources to feed the laws, like ethics, like politics, like whatever, culture. And these different visions of codes, if they're not fully aligned, will lead to different AI and different AI systems, and of course will lead to chaos. That is of course very obvious. So, for instance, China and the US and Europe have very, very different systems. On top of that, basically,
I remember well your first visit to Capitol Hill back in 2010. You spoke to the Senate Republican High-Tech Task Force, which I chair. You said back then that Facebook would always be free. Is that still your objective?
Senator, yes, there will always be a version of Facebook that is free. It is our mission to try to help connect everyone around the world and to bring the world closer together. In order to do that, we believe that we need to offer a service that everyone can afford, and we're committed to doing that.
Well, if so, how do you sustain a business model in which users don't pay for your service?
Look at his face.
Senator, we run ads.
Look at his face. So basically speaking, what it just tells here is that our politicians do not understand technology. This senator does not even understand how Facebook works. And we're not even talking about technicality or technology or anything like that. He's just dealing with the basic business model of Facebook. They're running ads, and this is why it's free. If it's free, you are the product. So you are prone to get ads from the system. That's the way it runs. And if these guys do not even understand that, how do you want them to understand the complexity of AI, the complexity of biases? They pretty well know what ethics and politics is all about. That's not what I'm saying. They are not stupid. But basically speaking, in terms of technology and in terms of technicality, they're way beyond. They don't understand the real risk in there. So even if we want to legislate, even if we want to define laws that are constraining AI, we are far away from reality here. Now, of course, that's very well to know that we have biases, but how do you hunt biases? How do you find them? Well, basically speaking, this is something that is extremely difficult to do. Well, first of all, here are a little set of hints I can give you. First of all, you need to know where to look. You've seen all these different steps while training and building a model. Well, at every step, you need to make sure that you have enough control, and you need to make sure that, well, at least you are representing the world the way you want it to be represented within your AI. You need to be, as a tester, if you want to test this kind of stuff, you need to be creative, twisted or critical. For instance, you can find some biases in Midjourney or this kind of image generating stuff, and of course that is very obvious that if you type things like dealer or CEO, now these algorithms are trained to give you loads of diversity in gender, skin color, and so on and so forth. So they learn from the past where it was heavily biased. But if you type something like Asperger, autistic profile or something, you might have a load of red hair people with Caucasian face and not smiling. And I can tell you, I know a lot of autistic people, basically. And there are ladies in there, they are smiling, they have a good life, and they are not red hair. All of them are not. So this is another bias. This is a way that we overrepresent a certain category of people. That's about experience. That's also about the classic. The classic are skin color. That's men versus women. That's about the kind of cliche that you have. All the Greeks are not walking like they are soldiers when they're doing the parade and so on and so forth. So all these kind of very cliche kind of stuff. That's about also the social trends. Today we have a couple of people that are very vocal about inclusivity and differences and so on and so forth, what we call the woke culture, basically. And yeah, if you want to protect your image and save your image, maybe you should have a look in there as well. And of course, everything that looks like a model, like you want to force the result or force the model within the AI instead of letting the AI find out the best way. Well, of course, you already bias the requirements up front or the algorithm front. Bad news here. Unfortunately, biases are often discovered very late and too late, because that's about the probability of detection. Biases do hide in the data, and it's not easy to find out. Sometimes the cure is worse than the disease. If you try to correct biases, you can lead to even more terrible biases. Like you have a black lady pope, for instance, that is definitely, well, we're not ready for that yet. The backlash, if often minimal, so bad publicity, contract termination, this is what you get, basically, because these AI algorithms are top secret. They're not disclosed to the world because people don't want to abuse the AI system, otherwise it has no value anymore. So they are inherently secret and bound to remain so. Okay, I'm ending up my presentation now. So please, well, if you want to confuse machine learning, this is a way. And check your data. And don't forget that you can very easily move from beauty to horror in the blink of an eye. And for this, I would love you to, close your eye a little bit. So half closed, and you will see the horror of the picture, though it looks like absolutely nothing. And this is a little bit the parallel with the biases that are hiding in the data. Okay. These are some references for you to take away. So I would definitely recommend you to watch the YouTube video of Alan Warburton, the Wizard of AI, and also the ones from Sabine Hossenfelder, Scientist War AI Collapse. And this is also the article that you can find where AI is decreasing when it's fed back with their own data. And that's about it, ladies and gentlemen. So thank you very much for your attention. I hope that you enjoyed the show and the presentation, and I'm all yours for the questions now. Thank you so much.
Olivier, thank you so much for an excellent presentation. Once again, you amaze us every year with your insights and your topics. Let's just have a look at what questions we have for you today. Firstly, we have, why are biases so difficult to catch or anticipate?
Oh, yeah. Well, basically because they hide. They don't want to be found. Actually, biases are not something that is very clear to find. You have a bunch of data. And I had this conversation with someone at a conference when I was also discussing about AI and biases. And the guy told me, well, if you look at the large language models today, like ChatGPT and so on and so forth, these guys have a lot of money and loads of data, like Google, for instance, with their own AI models. So the internet is their playground. So the internet normally, this is everyone, so it shouldn't be biased. And I just said, well, it's everyone. Are you sure about everyone? Have you got a grandma living these days? Well, mine are gone, unfortunately, but you can have people that are, 80, 90. Do you think that these guys are surfing on the internet every day? And even if they are surfing on the internet and learn how to use the PC and the internet, do you think that these guys are interacting a lot with the internet and publishing a lot on the internet? Well, probably not. So their voice is very, very tiny, if even so, compared to these YouTubers that are and these influencers that are blogging every day and vlogging every day and feeding the web with all kind of contents. So not everyone has the same weight So of course the data are biased, and the same goes with country-based or location-based. Not everyone in Asia or in Africa or in less developed countries, I would say, have an internet connection or a stable internet connection when they can interact and so on and so forth. So of course you have this kind of biases, and that's the reason why it's so hard to catch and anticipate.
Okay, our next question. How can you correct a bias that has been identified?
With extreme difficulty, actually. So this is very hard. Just like I said, 7 years ago, I was in China, and I was that was the first time. It was even before ChatGPT and so on and so forth, but we were starting to speak about artificial intelligence, and the project just started as well in the ISTQB to develop the syllabus. And I was invited in the Chinese conference, and I was there, and I was warning about the potential bias in artificial intelligence. And my example was I went to Google image, the tab where you have the image. You just prompt whatever, let's say, I don't know, a bike, and you have thousands and thousands of pictures of a bike. And there I just used 2 prompts, and one was CEO and the second one was dealer. And guess what? In the first one, I get, let's say, 85% of old white male people identified as CEO. So nearly no women, definitely very, very few people, Asian people or African people on the first page. Okay, and I displayed that, and I said that the audience was about 600 people there, and yeah, it was kind of professional audience, kind of decision-making audience. And I just said, well, I guess that there's no CEO in China, right? And everyone was laughing, of course, but this kind of, a little bit embarrassed kind of laughing. And this was Google at the time. Well, for dealer, guess what? It was mainly African people or black people, basically, most of them, let's say 90%. And of course, there are white dealers as well, and there are women as well that are dealing drugs. It's not because you're a black guy that you're per se a dealer. And this was also getting from Google. Of course, they improved. There was a lady called Timnit Gebru, and she was very attentive to that, and she did a very hard work there in Google to improve and solve the bias. Trouble that they fired her because of a controversial article that she wanted to publish, a study that she wanted to publish in kind of a science study, and they didn't like the conclusion, so they fired her. And they improved. So they changed the data basically in order to capture these kind of biases and try to mix and match a little bit better and get more diversity and inclusivity in their data. The trouble is, as I just said, you can also, by trying to correct a bias, induce another bias that is creating a heavier weight than in reality for certain categories of people, and you end up with a black female pope. And I guess that nobody is ready for a black female pope today. Well, I guess Christians are not ready for that yet. I don't care much, but basically, I guess that this is kind of a blasphemous kind of statement from me. So you see, or you have black Vikings, for instance, as well. This was a Google image generator as well. You had black Vikings. Black Vikings does not exist. It cannot happen. There was no possibility to have a black Viking at the time. So yeah, it's not easy. It's not easy. You need to correct the data, but you need to be very careful, and you need to retrain all over again and definitely control.
Of course, and I believe this is our last question. Apart from the elephant in the room, the obvious biases, what professionals using LLMs need to know today?
Okay, so what we talk about here were, the obvious biases, gender bias, skin color biases, the wokeism, and so on and so forth. These are, the ones that you identify quite easily these days, or that are identified for you if you catch them too late. Now, what I would like to recommend to professionals that are investing now in AI systems, and I know that AI systems are, introduced progressively in testing software and so on and so forth. Please do not fly blind. Do not rely blindly on what the AI gives you. And the big trouble is that what you get if you do a nice prompt engineering and so on and so forth, assuming that you know how to prompt, you will get a result that looks obviously good, and it is obviously good. 95% of it, 99% of it is obviously good. But unfortunately, a little tiny part, and this is my experience so far, is always wrong. You have a nice people that are generated in a group. Let's say you type an image for a team, and you have a nice team. But if you look at the hands of the people, some people have 6 fingers and some have 9 fingers or something, or you have an extra arm that is going on that belongs to nobody. So where is it coming from? You have results of a test. You just ask ChatGPT, okay, do equivalence partitioning on whatever kind of training example, and suddenly you have an answer. Yeah, please validate that there is no negative amount on the train ticket fee. But how do you want to get a negative amount on the train ticket fee? Because the data is input as a condition, and nobody will ever put a negative amount there, and there's no possibility for the data to be calculated negative, or maybe something changed by the time, but I can't understand. So these are the kind of things that you find out when you use the AI massively. So do not rely blind on the AI result. And this is where the humanity and the human testers can of course succeed. This is by developing the expertise that is necessary to check the AI results. So that's my advice for today.
I agree with you completely, Olivier. And once again, thank you so much for such an insightful presentation. I believe our viewers can take a lot from what you've presented and what you've stated today. To our viewers in particular, please stay tuned. We will be live again on the hour. And if you enjoyed Olivier's presentation, please go to our website and give him a vote as one of our best speakers today. Feel free to sign up to Skills Club as well, as we will be publishing all of our presentations on our Skills Club community. We look forward to seeing you in our next session. And Olivier, we look forward to seeing you again in our next conference in the year to come.
For sure. Thank you so much. You're up, guys. Bye-bye.
Thank you. Bye-bye.